if you watched our last video about these advanced sum and difference formula problems, you're going to recognize the beginning of these problems. We're going to start with still drawing two triangles. So in this case, we're asked to find the cosine of the difference of angles A and B. And so I've gone ahead and used the formulas we've talked about in class to break that apart into its different pieces. So let's go ahead and begin this problem by drawing our triangles. It's going to turn out that these problems are exactly the same as the last problems with one little twist to them. And that twist is they give you this right here, this inequality part. And really, this is just a fancy way of telling you what quadrant to draw your triangle in. Remember, when we first graphed with radians, we divided up our graph in like this. We said we'd start from 0 there. This top angle would be pi over 2. This would be pi, and this would be 3 pi over 2, and then we'd finished at 2 pi. So really, by giving you this inequality, they're just telling you which quadrant to draw your triangle in. For example, the quadrant that's between 3 pi over 2 and 2 pi is quadrant 4, this quadrant down here. So I'm going to go ahead and draw my triangle down there. So start from the origin and connect back to the x-axis. And then I'm going to go ahead and label the two sides just like we've done before. This time, notice that your ratio, one of those numbers is negative, either the 7 or the 25 is negative. Well, hopefully you recall that the hypotenuse is never negative. So my opposite side is going to be the negative side. Oops, I'll label that angle A, actually. And so also I know that that 7 is negative because it's going down in the triangle, or in the graph, so that's got to be a negative 7, okay? Just like we did before, I'll do Pythagorean theorem to find that third side. Or if you recognize this as a Pythagorean triple, you would know right away that that side's 24. Otherwise, you can do Pythagorean theorem. Recall, when you do that, make sure that negative 7 is in parentheses before you square it. So I could solve this and find out, yeah, 25 squared. I can find out that missing side is 24, okay? But let's leave it at that for now, all right? And let's go ahead and draw our second triangle. So again, the big difference is just this part is telling you what quadrant to draw your triangle in. Well, the quadrant that's between 0 and pi over 2 is quadrant 1, so this is back in quadrant 1, just like in our last video. This time they've given you the cosine is 9 over 41, so the adjacent side is 9. The hypotenuse is 41. And again, if you recognize this triple, you know that this missing side is 40. Otherwise, if you don't recognize it, or if it's not a triple, just go ahead and do Pythagorean theorem to find that third side. Okay? So our triangles are drawn, and now just like last time, again, very similar problem, same problem, other than that first step. We're going to go ahead and figure out what the sine and cosine of angle A is, as well as the sine and cosine of angle B. We'll take those values and plug them into our formula, and then we'll have our answer. So the sine of A is the opposite side over the hypotenuse, so over 25. The cosine is the adjacent side over the hypotenuse, so 24 over 25. And I'll do the same thing here on triangle B. So the sine of angle B and the cosine of angle B. Okay, and so getting those two ratios, the sine is the opposite over the hypotenuse, so 40 over 41 in this case. And adjacent over hypotenuse is 9 over 41. So lots of pre-work to do before we can actually begin this problem, or complete this problem, but once I have those four ratios, it's simply a matter of getting them plugged into this formula back up top. So to finish this problem, let's just plug these values in and simplify. So the cosine of angle A was 24 over 25. The cosine of angle B was 9 over 41. The sine of angle A was negative 7 over 25. Just be careful when you do this part. It's very easy to make a mistake because there's so many numbers you're looking at. Just look carefully, be patient. So 40 over 41. I'm getting a calculator out then if I need to do that to finish this multiplication. Go ahead and multiply the numerators and denominators of each piece of the fraction. So I end up with 216 over 1025 for the first fraction. What a lovely fraction that is. The next piece would end up being plus a negative 280 when I multiply on a calculator over 1025. Once again, we'll always have the same denominator for these problems. And because of that, I can very easily combine this into a single fraction. Add the numerators, I get negative 64 over that denominator of 1025. And so there is my answer to this question. Okay, we'll take a look at one more example, although it's the same idea, so if you think you got it, I'll have you try it on your own. Actually, in fact, I do want you to try the beginning part. Can you get the two triangles drawn? Can you find the sine and cosine of those different angles? And then we'll come back together and finish by plugging those values into this. So pause the video, try this part on your own, otherwise if you let it play through in a couple seconds, my work will pop up. Alright, so you can see the first thing I did was I figured out what quadrants to draw those two triangles in, based on the sort of parameters they gave me with those inequalities. So first triangle A was in quadrant 2, and triangle B was in quadrant 1. And then I figured out my missing sides using Pythagorean theorem. Remember, when you find that missing side, make sure you take -1 in parentheses and square it. And just be sure you're being careful with negatives. Remember, any numbers going to the left would be negative, any numbers going down would be negative. So I finished those two triangles. I found these ratios down here. Hopefully you found the same ratios. Once we have those, it's simply a matter then of plugging them back into our formula to find out the answer to the original question. So finishing this problem together then, we've got the square root of 15 over 4, that's the sine of angle A. Cosine of B was 4/5. The cosine of angle A was that -1/4, our only negative angle, or negative ratio, and then the sine of B was 3/5. So multiplying this out and simplifying, I end up with 4 square root of 15 over 20 as the first fraction, plus a -3 over 20 as the second fraction. And then again, adding those together to get a single fraction, I can't actually add the numerators together. They are not like terms, so the best I can do is say, as my final answer, 4 times the square root of 15 minus 3 over 20. And there is our exact value to this question.